More developers are switching away from Windows than ever before. Walk into any tech conference, scroll through any developer forum, or glance at the laptop lids in a co-working space, and the pattern is hard to miss. A growing share of the people writing the software the world runs on have quietly, or not so quietly, moved off of Windows. Some have jumped to macOS, others have gone all in on Linux, running distros like Fedora, Arch, Ubuntu, or Pop OS as their daily driver. A few have adopted a hybrid approach, keeping Windows around only for gaming or a handful of legacy applications, while doing all their actual development work inside WSL, a Linux VM, or a completely separate machine. But why? Is it performance, privacy, AI integration, or something else entirely? The honest answer is that it's rarely just one thing. Developers tend to be a pragmatic, if opinionated, group of people, and the decision to abandon a platform they've used for years, sometimes decades, doesn't happen because of a single bad update. It happens because of an accumulation of friction, broken trust, and a sense that the operating system is no longer built with them in mind. Today we'll look at the 5 biggest reasons behind this growing trend, and by the end, you'll probably recognize at least 1 or 2 of these frustrations from your own experience. Reason 1, the developer. Experience has become an afterthought. For a long time, Windows was simply where development happened, whether developers loved it or not. It was the default. It was what showed up on corporate-issued laptops, what universities taught on, and what most consumer software targeted. But default is not the same as designed for, and increasingly, developers feel like Windows treats their workflow as a secondary concern rather than a primary use case. Consider something as basic as the terminal. For years, the built-in command line experience on Windows was genuinely painful compared to what Unix-like systems offered out of the box. Microsoft has made real strides here, most notably with Windows Terminal and PowerShell, but even now many developers describe the experience as something that was bolted on rather than built in. Compare that to macOS or any Linux distribution, where the terminal isn't a separate semi-isolated feature, but the actual backbone of how the entire system operates. When your daily workflow involves constant shell scripting, package management, environment variables, and command chaining. Working against an OS where the terminal feels native rather than adjacent makes a real cumulative difference. Then there's the file system itself. Path length limitations that have historically caused headaches with deeply nested node modules folders, case insensitivity quirks that create subtle bugs when code gets deployed to case-sensitive Linux production servers, and a permissions model that doesn't map cleanly onto the Unix-style permissions most server infrastructure uses, all add up to a kind of persistent low-grade tax on development work. None of these issues are necessarily fatal on their own. Developers are used to working around limitations, but when every single day involves a handful of small workarounds that simply don't exist on other platforms, the cumulative frustration builds. Package management is another sore point. On macOS, developers have Homebrew. On most Linux distributions, there's a native package manager, whether that's apt, DNF, pacman, or something else, that's deeply integrated into how the entire system installs and updates software, including development tools. Windows has made progress with tools like Wingit and Chocolatey, but the ecosystem still feels fragmented and less mature, and a huge number of developer tools and libraries are still written, tested, and documented with Unix-like environments as the primary target. That's not a Windows failure exactly, it's more a reflection of where the center of gravity in software development culture has settled, but it means Windows developers are frequently the ones adapting instructions, patching workarounds, or discovering that a given tool technically supports Windows but clearly wasn't the platform anyone had in mind while building it. Microsoft's own answer to a lot of this has been WSL, the Windows subsystem for Linux, and to be fair, it's a genuinely impressive piece of engineering that has kept a meaningful number of developers on Windows who would otherwise have left entirely. But there's something telling about the fact that Microsoft's best strategy for making Windows appealing to developers was essentially to embed a Linux compatibility layer inside it. For many developers, that's less a reason to stay on Windows and more a stepping stone toward eventually asking why they don't just run Linux directly and skip the abstraction layer, especially once they get comfortable enough with it that the remaining Windows-specific parts of their workflow start to feel unnecessary. Reason 2, telemetry, bloatware, and a growing trust problem. If the first reason is about friction, the second is about trust, and trust erodes far more slowly than it's lost. Over the past several major Windows releases, a recurring complaint from developers and power users alike has been the sheer amount of telemetry, background data collection, and unsolicited software that ships with a default installation. Developers, more than most user groups, tend to be acutely aware of exactly what's running on their machines, what's phoning home, and what's consuming resources in the background, because diagnosing exactly that kind of thing is often part of their job. The presence of pre-installed third-party applications, recurring advertisements inside the start menu or lock screen, and settings that quietly reset themselves after major updates has created a persistent sense that the operating system's interests aren't fully aligned with the users. When a fresh install of an OS requires a 15-step process of disabling telemetry settings, uninstalling bundled software, and hunting through obscure registry keys or group policy editors just to get a clean, quiet, just do what I ask environment, that's a signal. It tells technically sophisticated users, exactly the kind of users developers are, that the default configuration wasn't built primarily with their interests in mind. Compare this to the experience of installing a minimal Linux distribution, where in many cases what you get after setup is close to exactly what you asked for and nothing more. There's no ad-supported start menu tile to disable, no bundled game demos to uninstall, no persistent nudge toward a subscription service you didn't ask for. macOS isn't quite as minimal as a bare Linux install, but it also doesn't carry nearly the same reputation for bundled cruft and background telemetry that Windows has accumulated over the last decade. This matters more for developers than for average consumers for a very specific reason. Developers are disproportionately concerned with system resource usage and predictability. A background process quietly consuming CPU cycles or network bandwidth isn't just an annoyance, it can actively interfere with build times, benchmark accuracy, and the ability to trust that a performance regression in your own code is actually your code's fault, and not some invisible background service competing for resources. When developers can't fully trust that their machine is doing only what they've asked it to do, that uncertainty becomes a recurring source of friction that pushes them toward platforms where the system's behavior feels more transparent and more within their control. There's also a broader philosophical dimension here that shouldn't be understated. A meaningful number of developers, particularly those working in open source, security-conscious fields, or privacy-focused industries, have an ideological preference for systems whose behavior they can fully audit. Open source operating systems allow that, in a way, closed source, telemetry-heavy systems simply cannot. You don't have to be a die-hard free software advocate to feel more comfortable on a system where, in principle, the entire stack from kernel to desktop environment is something you or the broader community could inspect line by line if you wanted to. Reason 3, the rise of Apple. Silicon changed the performance calculus. For years, one of the strongest practical arguments for staying on Windows, even among developers who might have philosophically preferred something else, was raw hardware performance and flexibility. Windows machines could be custom-built, upgraded, and tuned in ways that Apple's tightly controlled hardware ecosystem never allowed, and for a long time, high-end. Windows laptops and desktops simply outperformed their Mac equivalents on raw compute benchmarks, especially for compilation-heavy or resource-intensive workloads. That calculus shifted dramatically with the introduction of Apple Silicon. The transition from Intel chips to Apple's own ARM-based processors didn't just deliver incremental gains, it fundamentally reset expectations for what a laptop could deliver in terms of the combination of raw performance, sustained performance under load, and battery life. Developers who had spent years accepting that a powerful laptop meant a loud, hot machine that needed to be tethered to a charger during any serious workload suddenly had an alternative that could compile large codebases, run multiple containers, handle demanding IDE workloads, and still deliver all-day battery life, all while running close to silent. This mattered enormously for a specific, very common developer use case, working away from a desk. Whether that's working from a coffee shop, traveling, working from a couch, or simply not wanting to be chained to an outlet, the practical value of a machine that delivers workstation-class performance without workstation-class power and heat requirements is hard to overstate. Windows laptops, particularly those built around x86 architecture, have historically struggled to match that combination. And while Windows on ARM has existed as a concept for years, application compatibility and ecosystem support for that platform have lagged far behind what Apple achieved with a controlled, vertically integrated hardware and software stack. It's worth being fair here. This isn't purely a software or philosophical argument. It's a genuinely practical dollars and cents and hours of battery life argument. And that's exactly why it's been so persuasive to developers who might not otherwise have cared about switching platforms. A developer who was previously indifferent between Windows and macOS on ideological grounds can become a convert purely because their new machine runs cooler, lasts longer, and gets out of their way more effectively. Performance arguments tend to be the most persuasive precisely because they don't require anyone to change their values, only their hardware. It's also worth noting that this shift has had ripple effects beyond just Apple's own ecosystem. The success of Apple Silicon put pressure on the entire industry. accelerating interest in ARM-based computing more broadly, including ARM-based Linux hardware, and even Microsoft's own renewed push into Windows on ARM. But Apple got there first, and got there decisively, and a first-mover advantage in developer mindshare is difficult to claw back once a critical mass of influential developers, the kind who write blog posts, record conference talks, and influence hiring decisions at their companies, have already made the switch and are vocally happy with it. Reason 4. Linux and macOS compatibility with modern dev tooling. The modern software development stack has increasingly consolidated around tools and workflows that were built first, and sometimes exclusively, for Unix-like environments. Docker, Kubernetes, most CI/CD pipeline tooling, a huge swath of cloud infrastructure tooling, and the vast majority of production server environments all run on Linux. When the environment you're deploying to is Linux, there's an obvious and compounding advantage to developing on a system that behaves as similarly to that production environment as possible. This is sometimes called dev-prod parity, and it's a principle that many experienced engineering teams take seriously, because the alternative, developing on one type of system and deploying to a fundamentally different one, is a well-documented source of "it works on my machine" bugs. Subtle differences in file system behavior, environment variable handling, line ending conventions, case sensitivity, and process management between Windows and Linux have caused real time-consuming production incidents throughout the industry's history. Developers who have been burned by this kind of mismatch even once tend to become fairly committed advocates for closing that gap permanently by simply developing on the same kind of system they deploy to. Containerization technology has helped narrow this gap somewhat, since Docker Desktop on Windows and WSL2 integration have made it possible to run Linux containers relatively seamlessly, even on a Windows host. But there's a meaningful difference between relatively seamless and native, and developers working with performance, sensitive workloads, complex networking configurations, or tools that assume a genuine Linux kernel underneath them, frequently run into edge cases that simply don't exist when working on an actual Linux machine or on macOS, which shares enough Unix DNA to avoid most of these issues, even though it isn't Linux itself. Beyond containerization specifically, there's the broader question of tooling maturity. Many popular developer tools, ranging from niche command line utilities to major frameworks, are developed by teams who use Linux or macOS themselves, which means those platforms tend to get first-class support, faster bug fixes, and more thorough documentation, while Windows support is often maintained as a secondary target, sometimes by a smaller subset of contributors, sometimes lagging behind in feature parity. This isn't universally true. Plenty of major tools have excellent, well-maintained Windows support, but the pattern is common enough that developers have learned to expect it, and expecting friction tends to become a self-fulfilling reason to avoid it altogether by switching platforms. Package ecosystems compound this further. Python developers dealing with certain compiled dependencies, developers working with GPU-accelerated machine learning frameworks, and developers working with systems programming languages that assume POSIX compliance all tend to report smoother experiences on Linux or macOS. Even when a Windows equivalent exists, it frequently requires additional configuration steps, alternate build toolchains, or workaround libraries that simply aren't necessary elsewhere. Multiply that friction across the dozens of dependencies a typical modern project relies on, and the cumulative time cost becomes significant enough to influence platform choice on its own. Reason 5. A growing preference for customization and control. The final major reason developers are leaving Windows is less about any single technical deficiency and more about a broader desire for control over their own computing environment, a desire that Windows, by its very design philosophy, is structurally less able to satisfy than Linux in particular. Windows is built to serve an enormous, diverse user base, ranging from casual home users to enterprise IT departments to gamers to, yes, developers. And that breadth necessarily means compromises. The operating system has to make sensible default choices for hundreds of millions of people who will never open a terminal, never customize a window manager, and never care about init systems or kernel modules. Developers, by contrast, are exactly the kind of users who often do care about those things, sometimes intensely so. And Linux in particular offers a level of granular control that simply has no equivalent on Windows. On Linux, a developer can choose their init system, their display server, their window manager or desktop environment, their shell, their package manager, and effectively every other layer of the stack, mixing and matching components to build an environment precisely tailored to their workflow and preferences. Want a completely keyboard-driven, mouse-free workflow built around a tiling window manager? That's a well-trodden path on Linux, with mature tools and large communities built around exactly that use case. Want a minimal system with the absolute fewest background processes possible, stripped down to just what's needed to compile code and run a terminal? Also entirely achievable, and in fact a fairly common project among developers who enjoy building and maintaining their own custom setups. This isn't purely aesthetic tinkering either, though there's certainly an element of genuine enjoyment in customizing one's own tools. There's a real productivity argument underlying it. Developers who spend 8 or more hours a day inside their computing environment have a strong incentive to shave friction out of every repeated interaction. And a system that allows deep customization lets them do exactly that in ways a more locked down, one-size-fits-all operating system cannot. Custom key bindings, scriptable window management, deeply configurable terminal emulators, and the ability to automate nearly any repetitive task through shell scripting all compound over time into meaningfully faster, less frustrating workflows. There's also a community and cultural dimension to this that shouldn't be underestimated. Communities built around tools like Arch Linux, Fedora, various tiling window managers, and heavily customized .files repositories have become genuinely vibrant spaces where developers share configurations, troubleshoot together, and take real pride in building something tailored specifically to how they think and work. That kind of community enthusiasm is self-reinforcing. As more developers post their custom setups, write about their workflows, or stream themselves building and troubleshooting these environments, more developers are exposed to what's possible and become interested in trying it themselves. Windows, with its more standardized and centrally controlled interface, simply doesn't generate the same kind of grassroots customization culture. Not because Windows users lack the interest, but because the platform's architecture makes that kind of deep, layer-by-layer customization considerably harder to achieve. Closing thoughts. None of this means Windows is disappearing from developer workstations anytime soon. It remains the dominant desktop operating system worldwide. It has an enormous existing user base among developers, especially those working in game development, enterprise.NET environments, and other Windows-centric ecosystems. And Microsoft has made real meaningful investments in developer experience over the past several years, WSL being the most obvious example. Plenty of developers remain perfectly happy on Windows, and for certain workflows, particularly those tied closely to the Microsoft ecosystem, it remains the clearly superior choice. But the trend is real, and it's worth taking seriously precisely because it isn't being driven by any single dramatic failure. It's the accumulation of smaller frictions, a developer experience that often feels secondary rather than primary, a growing trust deficit around telemetry and bundled software, a hardware performance and efficiency gap that Apple Silicon opened up and hasn't fully closed, a tooling and infrastructure ecosystem increasingly built around Unix-like assumptions, and a cultural and practical desire for the kind of deep customization and control that Linux in particular makes possible in a way Windows structurally cannot. Whether this trend continues to accelerate, plateaus, or gets meaningfully reversed by future Windows changes remains an open question. But for now, the direction of travel among a meaningful and increasingly vocal segment of the developer community is clear, and it's a trend worth watching closely, both for what it says about developer priorities today and for what it might mean for the future shape of desktop computing more broadly.